Alright guys, this is a video to help you out with worksheet number 3, parallel circuit problems. And this worksheet for a parallel circuit is different than it is for a series circuit, which was worksheet number 2. So on a parallel circuit, you have more than one pathway for the electrons to flow through. And the rules are different in that in a parallel circuit, the voltage is the same in every part of the circuit. The current adds up, and the total resistance is equal to 1 over the sum of the reciprocals of all of the circuits. So this is the one that is the hardest for everybody, and it's actually the first problem here too. So I'll just write down the formula for this. The resistance total, I'll put the total resistance, RT, equals 1 over the sum of the reciprocals, resistance 1 over resistance at number 1, plus 1 over the resistance at place number 2, plus 1 over the resistance at place number 3. And I'll put a dot here at the end. It just shows that if you had another resistor, like resistor number 4, you would add 1 over that resistance. However many that you have, you'd go 1 over R4 plus 1 over R5 plus 1 over R6 plus however many that there are total. Okay, so that's it. This first example here, I'll do this problem for you. You have 3 resistances. Resistance 1 is 20 ohms, resistance 2 is 15, and resistance 3 is 8. So our equation for this is 1 over the reciprocal at resistance 1 is 1 over 20, plus the resistance at number 2 is 15, so we go 1 over 15, plus the resistance at number 3 is 8, so we go 1 over 8. So we have 1 over 20 plus 1 over 15 plus 1 over 8. Let's do the math for that. So we say 1 divided by 20, and then we're going to add 1. Oops, I didn't put that in the right place here. Sorry about that. All right. So let's add 1 over 15. 1 divided by 15. And to that, we're going to add 1 divided by 8. So when we do that, we get 0.24166. Okay, but remember that we have to go 1 divided by, because here's our formula up here on the top. Let me change the color here a little bit. So we have 1 divided by the sum of these reciprocals. So in order to solve this problem, we have to go 1 divided by our answer that we got from the previous problem was this. Let's just go 0.242. 1 divided by 0.242. I just rounded it off to 0.242 instead of 0.2416666 is various 6s and a 7. So we get 4.132. 4.132 will be our answer for that. .132, and that would be ohms is resistance. That's how you do that kind of a problem. So you guys have question number 2 to do. Same way. And then we have another table like we did in worksheet number 2. We have the same thing in worksheet number 3, where we're given the resistance at position. Here we have position 1, position 2, position 3. And here's position 1, 2, and 3. These are just resistors that are put in a parallel circuit. And then we have our battery here, which is going to provide all of our voltage. We're given the total voltage as well as what the resistance was at each one of these three positions, resistor 1, 2, and 3. We do not know what the total resistance is. We do not know what the current is in one of these, and we don't know what the voltage is in any one of these as well. So that's where we've got to solve for this problem. So to find our total resistance, okay, again, we just go 1 over 5 plus 1 over 10 plus 1 over 20. Where did we get the 5 and the 10 and the 20 from? Right here, and right here. Okay, the resistance right here. Okay, so that's how we do the problem, and we just need to put the numbers into decimals calculator. We go 1 divided by 5 plus 1 divided by 10 plus 1 divided by 20. Oops, I didn't need to do that. Gives us our answer is 0.35, but remember, we're going to divide 1 by that answer. 1 divided by 0.35 gives us 2.857. 2.857 is our 2.857 will be our total resistance. Okay, then we can calculate our current. Remember, like we did with the series circuit, we have an equation that says voltage equals current times resistance. We know our total voltage is 9. We don't know our current, but we know that our resistance is 2.857. So if we divide both sides by 2.857, that will cancel that out. 9 divided by 2.857 9 divided by 2.857 gives us 3.150. 3.150. Okay. Now remember, for a parallel circuit, the voltage is the same everywhere. So we could have written this in 9, 9, and 9 right there as our answers for the voltage right away without ever doing any other kind of math. But we didn't. But now we're going to use that. And remember that the current, the total current adds up. So the current here, here, and here needs to add up to 3.150. So let's do the math here and figure it out. As the same way that we did it in the previous problem, we did 9 divided by 2.857, the voltage divided by the resistance to get the current. So for position number 1, we're going to do again the voltage divided by the resistance. In this case, 9 divided by 5. 9 divided by 5 for position number 1. 9 divided by 5 gives us 1.8. And that's going to go right here, 1.8. Okay, the next one will be 9 divided by 10 for position number 2. Oops. 9 divided by 10 gives us 0.9. 0.9. And the last position is 9 divided by 20. Gives us 0.45. And if we add them up, 1.8 plus 0.9 plus 0.45 should give us the total current. Let's see if it actually adds up. 1.8 plus 0.9. Oops, why did I do that? Did a minus, let's do a plus. 0.9 plus 0.45 gives us 3.15. And that's exactly what we had, 3.15. That's how you do these problems. You guys will have the same problem, same way to do. First thing you're going to do is find the resistance. Okay, then you can use Ohm's law to find the current. Remember, the voltages are all the same everywhere. Then you can use Ohm's law, voltage equals current times resistance, to get the current in these different spots. Email me if you have any questions. Good luck on this. Yeah, that's all.